Hello, welcome to this tutorial, and today we are going to create a very simple timber truss in Tekla structures, and we are going to use US environment. Please join me. I'm Morris Dimba, and if you take a look on the screen here, you can see a simple grid line. So this will just act as our guideline, but by default when you start Tekla structures, the grid line will come differently depending on which environment you are using. Now, that aside, let's now start marking out our truss. Now, I'll come to edit here, then come to points under view, then pick online, this option online point. Then I want to create a midpoint in between these 2 points because I want to define my apex height. Now I'll click on that spot and click on this spot right here, and I'll get this green spot here. So I want to offset it up by 2.5 meters high. Now I select on it, right click, and come to special copy here and pick on that. Then on Z axis here, I want to work with the Z axis because it's the only axis pointing up. If you take a look on the on this side, on my right hand side here, so let's change everything to 0 except that axis. So I'll come to Z axis and feed in here 2.5. Then I'll go ahead and click OK. Then you'll see it moving up. Now I'll close this. So once I've closed that, I want to now try to map out how my truss will look like. Now I'll come to view once again, not view, I'll come to edit. So the moment I click edit, I'll be able to access this tool here, this construction object. So I'll click this drop down arrow under construction object here because I want to use a line. So I'll click on that line, then I'll snap on that spot and create a line there, and create another line here, and create another line here right there. So I'll create another line there moving up. So you'll find that whatever we did was not accurate. So let me come to navigate and turn this around like this. You'll be able to see we snapped on a wrong point. So let's do this. We'll get rid of this line and come back again and start creating another line. I'll come to edit and snap on that and click this drop down arrow and pick the line. So I want to snap on top here and snap at the bottom end here. So if I come to view, I'll be able to, if I come to view here, I'll be able to come to navigate, I'll be able to rotate my model, my simple line work like this. So I want to create another line here, moving all the way down. I'll come there. I don't need a point, I just need a line. I'll create a line here and place it right there. So I've not placed a line, I've placed a point, which we didn't want to create that. I'll snap there and create another line right there. So I'm going to create another line, come here and select on this, select on that, and I want to snap here, and I want to snap at the midpoint of that. So the next thing I'm going to do is to create another line. Snap here and create another line there. Snap there and create another line there. So let me come to view and check this. So we have a simple line work here. These are just guidelines to guide us in placing our timber. So once you've done this, now we'll go back. We'll go to placement of the profiles or sections. In this particular case, we're going to use timber as our section. Now I'll come to steel here, and this because normally Tekla structure is divided into steel and concrete. So timber falls under steel. So I'm going to use steel. I'm going to use beam here under steel, and I want to define my rafter from that end going all the way to this end, and I'll terminate it right there. So if I come to view here and I want to rotate this, you'll be able to see we have a timber here. So I'm going to double click on this so that to check on the properties of this particular component or this section, and this is how it looks. But the way it sits on top here is not good. We'll try and rotate it. So first of all, before we reorient the position of this component, let's first of all check on its properties first. So I'm going to double click on it first. Then if you take a look here, we have the profile, but it is defined as a beam. So you can either type here a timber, you can either type there timber if you want, double click once again, and it comes back where it was because we didn't save it. So the way it is now, let's click on this radio button just adjacent to this text, S4S 4x8 timber. So let me click on that. So if I come here, this will take me, the moment you click on this drop down, this button here will take you straight to profile catalog of all these sections. So let me minimize this, and you'll be able to see we are under timber profiles. So under timber profile, we have soft metric conversion, we have glulam, plywood profiles, we have laminated strand lumber, we have laminated veneer lumber, we have parallel strand lumber, we have rough sawn lumber, we have finished 4 sides, S4S. So we are going to use this profile here. So I'll click this plus sign. So if the moment you click that plus sign, you'll jump into variety of timber profiles here. So it will stretch all the way to 24 by 24 timber size. So in this particular case, we're going to use 4 by 2 or 4 by 8 for our rafters, and the same, just to show you how to work with timbers, and to show you that we have timber profiles in Tekla structures and US environments. Now let me just scroll up and pick any of these. Now it's all dependent on your choice of timber profiles and timber sizes. So in my particular case, I'm going to use 4 by 8. Let me look for 4 by 8 in this profile catalog. So let me just scroll down here, and I'll snap on that. If I click apply and I give it an OK by clicking on OK button there, then you'll find that it will our modify button is not active because whatever we've just chosen is present here. So there's nothing more to apply as a new change. So it will remain as a gray button like that. So the next thing I'm going to do, just double click here just to change how it sits on top here. So I double click once again and come to position, and under position we have 2 options. We have on the plane, rotation, and arc depths. So the section we are going to work with is rotation. This rotation will be able to tilt this member and sit in the right position. So I'll come here and click that drop down arrow and pick either of these 3 choices. We have front, top, back, below. Then let me just click back and see how it rotates, or below, and see how it rotates. It rotates like that. So our center line is cutting across the middle point of this component. So we want it to sit right below our construction line. Now let's come here and on plane and click right and see whether how it will behave with that line. It's not the best option. Let's work with updates and pick the front line. That one also will not work. Let's work with behind. So that one will work. So if you come to navigate and try to rotate this, you'll see how this behave. So since we still want to work with this, and we can still leave it in that position, we don't need to change it. And once we have this, remember we are working with this profile, with this timber size 4 by 8. And now let's go on and work on our truss. I'll come to steel here and pick on the beam, and I'll snap on top here and stretch all the way to the bottom end here, and snap on this intersection there. So once you've done that, we are going to place this bottom chord for our truss. I'll come back to beam here and define it from that spot and stretch all the way to this far end. That far end. Don't worry about the span. The span, it's upon you on how many joints you'll create to join your timber. So let me just show you the span of this. I'll come to edit and come to measure, and I want to show you the span of this truss. It should be 13.5. It is 13.5, and I think we can get a span of that kind for timber sections. Now I want this bottom chord to slightly move up, so I just double click. I'll double click on it and come to under positions here and pick this option of arc depths and click on that. Then click either front and click OK, and it will move up straight to the upper section. So as we go on, we'll just trim this and we leave this for connection to the beam. Now I'll close this. So the moment I close that, I'll continue placing my truss struts. Now I'll come to steel and pick on that, and I want to snap on this spot and move all the way to this position right there. So the moment I snap here, you'll find this is not landing or not position itself right at the center. So that shouldn't worry you. Should not worry you. Just double click on it and come to this to its properties here. This is the point you'll be able to position it, whether on the side or or at the middle. So I've double clicked on it. So the moment you double click on it, this will prompt these dialog properties of this particular beam or this component to come on your right side. So the moment it come, and now depends on you which component or which section do you want to work on, or do you want to work on, do you want to change the profile? You'll target the upper section under general. Numbering, it's automatic by default. You'll work with these numberings, or you can change this. So as like in our case, you don't want this to be defined as a beam, because it will sound like a steel component or a steel profile. So in this particular case, you just type here timber. Just type timber. Right there, it's timber 4x8. Now, the moment you do that, and prior to going back and forth, we just want to make these two changes. One, go and click modify button. Now we want to shift this member to apply as to support our top chords right at the center, right from the center here. So I'll come to vertical section or horizontal section. I'll click on this and pick middle. So this will come right in the middle. There we are, and come to steel beam there and snap on this position, then move all the way to this position, and I'll snap on that spot and come all the way to the bottom end here. So if you take a look here, it's not snapping right at the center. So let's see how this will behave with this one. It's upon us to either shift it or double click it and bring it to the midpoint, or we just leave it the way it is. Let me just double click on that and shift it and bring it maybe to front or behind. Let me just click that and it lands there. That will not be the best position, because the connection will create some difficulty. Let me just come back here and try and click middle, and it will shift to that position. We can decide and leave it on that position. So what I'm going to do now is just to select these two and mirror them the other side. Let me close this, and to mirror that, we have to change, or you have to change the position of your z axis. And to change that, let me first of all minimize that. To change your XYZ axis, you just come to view, and a view, you come to work plane tool, click that drop down arrow and pick the first option, work plane tool. I'll click on this, though there are several options, but this one work best and work faster. I'll come to work plane tool, select on it. So the moment you select on it, you'll be able to pick on where do you want to place your plane to define your XYZ, your custom XYZ plane. So just mouse over any component, and we want our Y to come up. We want to place it somewhere here. We want that axis. So YX and the Z pointing horizontal, both positive and negative. Now I want to mirror this. I'll select this component. I'll select this timber and select this timber. Then right click and come to special move or special copy here and pick on the mirror option. So I want to mirror the two components on the opposite direction. So I'll define this point as my mirror line and terminate it right there, and you can see the angle and the distances of the two components on y-axis and and the x-axis. You can see the distances and the angle of the movement. So I'll go ahead and click copy. The moment I click copy, you'll see those components mirroring on the opposite direction. So that's how we'll work with them. So we have these struts in here. So we can still try and work and try and change the positions of these struts. Now I'll come to positions here under at depths and select on that and try to change that. It's not the appropriate option. I'll come on plane here and try to move it right. We can snap it there, but still not the best option. The best option is not the best option yet. Now let me just undo, and we'll just leave them in that position. So let's move on and try to trim all any protrusion of any component into the other or clashing parts. So we want to cut this member so that they have a mitre connection. So to do that, we can cut it manually, but that will take some bit of time, and we normally cut down on time on presentation. Now we have this component and this component. This component is protruding inside this, and this one protrudes inside this. So we want to create a mitre connection in between these two. So we'll come here and use some tools for steel connections. So I'll come here and type mitre and select on that component, and I want to connect this to this by mitre. So connection is mitre, and you can see the weld here. So when you create your drawing, when you create the drawings, you'll be able to customize this connection as either a connection or as either a gusset plate connection, bolting these two components or these three components. So let me first of all disable this as you disable this assembly and select on that button. Select on that button so we can get rid of these welds, so that it doesn't bring confusion as if these two components are steel profiles. So we've connected this using a mitre tool. So we want to also to cut this timber to follow the profile of these two components. So how do we do that? We do that by defining this contour. So we'll come to edit here and come to points just to help us follow the path of this profile. So I'll come to at any position and try and snap on these points. I'll snap on these points right there, and snap also on that spot. Snap there and snap here. Just mouse over accurately so that you snap on the accurate positions. So the moment you've defined a contour like this, we want to cut off this extended member of this profile. So to cut it off, we just come to edit. So under edit, you'll get the tool, these three tools: polygon cut, line cut, and part cut. So in this particular case, after defining your polygon, I'll come to, after defining your contour points, I'll come to polygon cut and follow the profile, creating a polygon. So first of all, the moment you activate this, just come here and select on the component you want to cut off using this option of polygon cut, and start with the first point. My first point will be this point, and I'll move to the second point, I'll move to the third point, and follow this profile until you come to your initial spot. And the moment you come to your initial spot, it will trim off or cut off that extension or unwanted part. So I'll click on that, and that point will be trimmed off. It hasn't been trimmed off yet because the part that touches here has been trimmed off. The option we took was not appropriate, and we are going to take another one that will work perfectly. So I'll come here and click undo to bring that component back, to bring that component that we trimmed off by mistake. And we'll come back to edit here and click on edit and come to polygon right here. So I'm going to select this component here and start defining the parts that the parts I want to trim off. So I'll start my point. I'll start this point as my first point and go to the next point as my second point, like that, and select on that. Come all the way to the top end here and come to my initial spot, and the moment I click on that, I'll get rid of that unwanted section. So you will realize the moment I redraw, I'll either lose all these line works, but still I don't want to redraw to lose those line works because I still need some information from them or a guidance from them. So I'll only get rid of them by redrawing, by clicking redraw to refresh my screen, and I'll get rid of them one go. So let me first of all show or define the connection between this top chord and this strat. Now I'll either connect them by a mitre, a tool that is normally applicable on steel connections, but still we can apply it here, knowing that this is a steel connection, but you can apply it here. So when you generate your drawings, you know how you detail this and define this connection. But in this particular case, in the next presentation, I'll show you how we can apply bracket connection for these timber members. Now let me connect this to this. I'll come to mitre, and mitre will not work here. We are going to use a tool for weld. We are using this tool just to help us in connecting, in creating connection between this and this. I'll come to stanchion and I want to connect this to that. So you see that trimming. So we are using this tool to trim this component to that. So I'm going to trim this to that, and also trimming that to that. And I want to trim this to this, and you see how this trims perfectly and faster instead of cutting it manually. So we are using this to trim off, but not to connect timber. You cannot connect timber by weld. You only nail or bolt by using gusset plates. Connect that to that, wrong connection, and we'll connect that to that. So once this has been done, we can go ahead and redraw and in one strange thing in US environment, redraw doesn't get rid of any sign of macro or any point. So I'll come to view and try rotate this. You see we have our truss in place, and it's as simple as this. So I'll get rid of this. So if I double click on the screen here and type here 180 and I place 0 here, we can see a section, a side view of this. And if I change this to 90, I'll be able to see a section view of this. So this is how we can do this. I'll get rid of that. So keep following this process of truss creation using a timber. In the next presentation, I'm going to show you how we can use gusset plates to create joints in this timber truss creation. Thanks a lot for watching. If this is your first video you've just bumped into, please don't forget to subscribe, and let's meet on the next presentation. And prior to that, let me just turn this round so that you see how it looks. I'll just turn it round and you see how this one looks. We can either decide to use nails to create connection, but nails are not really trustable because timber sometimes they wear out, and the connection it tends to sabotage the loadings that are on top of it, so which may sink in, which might be disastrous to people living under this roof. So nowadays the light gauge profile are now taking over, people running away from timber structures. Now this is how it looks, and if I come to navigate, I'll be able to rotate this, and you can see how these timbers have been arranged in Tekla structure, and this is how it's done. Thanks a lot, and bye bye, stay safe. Thank you.